Hi, this is Stephen Brower from Mountain Valley Community College. This is to accompany Irvine Chapter 11 on using the Windows API. There is a demo that is in Canvas. Sorry. Okay, here eventually. Heap User Driven is the demo that is up in Canvas. And what I'm going to do is try to show what's going on in terms of memory while that is running. One other thing I also do want to show, oh boy, I got too many windows open, is the use of memory. That's expanding too much. The use of memory while the process is running. So let's, well, let me start this. Okay, so the program is running, and what happened behind the scenes is it went and it got the handle for the heap, and then it made a backup of the handle. So initially the handle was left in EAX, and then it made a copy of it into a variable. And so what this here, this pheap does is it is referring to the heap, which is dynamically allocated memory that the operating system will give to a process. So that happened behind the scenes where, not behind the scenes, in the beginning of the program is where that command was done. What we're going to do here is we're going to ask for the program to allocate a chunk of memory. So I'm going to put in, let's see, hundreds, thousands. So this is 268 million. It ends up being 256K. I'm sorry, 256 meg in terms of the number of elements I'm asking for in the array. Now, there's 4 bytes in a D word, and so what they'll end up being is 1 gig in size. So now let's switch back to this task manager again, and what we should see here, sorry, this one right here. This project right here, this is us. And this is taking 400K of memory right now. When I hit enter, what it's going to do, and actually let's come back here for a second. When I hit enter, it's going to ask the operating system from the heap for a chunk of memory. And so using the handle to the heap, it's asking for array size. Now, when I do hit enter, the array size is actually going to be in bytes. So it's going to be this number times 4 to represent basically a gig of memory that it's going to ask for. And here we're asking it to do us a favor, 0 it out. So all the elements are 0. And then the handle will be in EAX, of which then we'll go and we'll make a copy of it to this P array. Okay, so here, I'm replicating what would happen in the classroom, which is a total. Okay, so as soon as I hit enter, it's going to do that allocation. So as you see right now, we're at 0.4 meg, so 400K. I'm going to hit enter. We now have a gig of memory. And then the other thing it did behind the scenes is it filled in the memory. It filled in that 268 million elements to a random number. So what had happened next is the fill array went and filled in everything. So at the present moment, okay, our application is using 1 gig of RAM. And the memory that it's using, we requested, so that's the gig right here, logically I'm showing here. So this would be the 268 million elements, 268 million D words, which is 1 gigabytes. So 1 gig is what our program is using at the present moment. What I will do next is we will release the hounds. We'll get rid of the memory that we have. Whoops, I'll get this right. And so I'm about to do that heap free to release what we've taken from the heap. And so this 1 gig, we should see, goes down back to where it was before. Now our program is still running, and we're just not taking up the amount of memory that we've done before. In some other languages, it's extremely important after you allocate and use something that you free it. Otherwise, the operating system may not know that it can take that memory and use it elsewhere. So it's important for us to free the memory when we're done. So here, when I just do one more, the process will end, and then that part here is gone. Okay. So what's the whole point again? Before I end this, the point is that there is this heap of memory that is dynamically allocated for our process. We can get access to the heap by getting the handle for the heap, and then we can do things like alloc. We actually can allocate a chunk of memory in the heap, but when we allocate that chunk of memory, we have an address to the beginning of that hunk of memory, and then what we do is we would have to then manage that hunk of memory on our own. Now, since I was doing it as an array, so let's just back up to here again. Since I was doing it as an array, I just used the pointer to the beginning of the array, and then I manage then 4 bytes at a time to be all the elements that it has. When we were done using it, we freed it up. Okay, that's it for the semester. That's all, folks. It's been great.